Okay, so the recording has started. So good morning, everybody. Welcome to Math 115. This is a pre-calculus course, so I think that everybody who's here should have either taken Math 111 before or has placed into this class via the math placement test. So before we get started, I just want to introduce myself and also get to know a tiny bit about you. It's going to take me like a week or two to start getting names down, but I got to start trying somewhere. So here's what I'd like to do. So first I'll introduce myself, and then what I'd like everyone to do is I'm going to come around and I'd like to ask you your name, what is your major, and then one thing that you want to do before you die. So I'll introduce myself first. My name is Thomas Homery. I am a fourth-year graduate student. Hi, good morning. I'm a fourth-year graduate student in the mathematics department, which means that I am trying very hard to get my PhD. I'm hoping that I can graduate at the end of this year. So this could be the last year for me, but we'll see. So if you're interested in math, I study a subfield of mathematics called partial differential equations. Basically, things that change in space and in time. So what else about me? I've taught this course once before, and I've taught several other courses here at U of SC, so fingers crossed, you should be in good hands. And one thing I want to do before I die is climb this thing, which, if you've never seen this before, this is a structure called the Devil's Tower. It's in, I don't even know where it is, Oregon or Washington or something like that. And it's actually got a kind of an interesting story because you see it has all of these like marks like coming down it. And apparently there's a legend that someone was being chased by like a magical giant bear or something. And they hid on top of the tower, and the bear was trying to get up, and so it was like clawing at the tower, and that's what made all of these grooves in the side of it. So I think that's kind of cool. And I think it would be cool to go on top and like, role play like the guy who was hiding from the bear. Okay, so I'm going to start down in the front row, and then we'll work our way into the back. Could I just have your name, major, what you want to do before you die?
Okay, hi, I'm Piper. I'm a biology major. And probably one thing I want to do before I die is either visit Ireland or Scotland.
Nice, Ireland or Scotland. Any particular reason why?
It's just cool.
They are cool. Right.
I'm Lily. I'm a biochemistry major, and I guess I was going to travel a lot before I die.
Nice. Traveling's always great.
My name's Thomas. I'm a biomedical engineering major, and yeah, I'd like to travel.
Okay.
I'm Caroline. I'm a biochemistry and molecular biology major, and I would like to see some of the rare birds in the world before I die.
Nice.
I'm Madeline. I'm a mechanical engineer major, and I would like to travel.
Okay.
I'm Jacob. I'm a mechanical engineer major, and I think I want to skydive before I die.
Skydive. Terrified of heights. Contradictory to my wish. But I feel like with skydiving, I feel like at least if you're climbing, you're kind of in control of your own destiny, like to some extent. But when you're skydiving, it's like that thing doesn't open. I feel like you're just kind of screwed. All right.
My name's Olivia. I'm a civil engineering major.
Okay.
And probably go on stage with this movie or something soon.
Okay. Yeah, that could be cool. All right.
My name's Sully. I'm a marine science major and just travel.
Okay, nice to meet you.
I'm Connor. I'm a civil engineer, and I probably want to surf in Hawaii before I die.
You want to go on like one of those giga waves that are like 100 feet tall?
Probably die.
Yeah, those are scary. Apparently those things will if they crash down on you, they'll hold you down for 2 minutes or something like that.
Yeah, that's right.
That's scary. Okay.
I'm Emma. I'm a bio major, and the one thing I'd want to do is probably backpack through Europe.
Amazing.
I'm Lily. I'm also a marine science major, and I want to scuba dive on the Great Barrier Reef.
Oh, that's nice. I've actually done that before.
Really?
Yeah, it's beautiful. Well, not scuba dive, snorkel. Sorry, I always get those two confused.
I'm Lakin. I'm also a marine science major, and I just want to travel.
I'm
vascular technology major, and I want to go to Greece before I die.
Greece. Nice. Any particular reason why?
I'm Greek.
Okay.
I'm Carter, I'm a bio major, and I want to skydive before I die.
Sweet.
Good morning, I'm Ashley, I'm a geology major, and I would like to be able to call myself a climber before I die.
Nice. Okay. Cool.
My name is Randall Pete. I'm a computer engineering major, and I also want to skydive, but I want to be on the flying suits where you can like control how
Okay.
you fly.
Yeah, those are cool. Those are cool.
I'm Emily. I'm a marine science major, and I want to scuba dive for the Great Barrier Reef too. So.
Sweet.
I'm Chris. I'm a civil engineer major and want to graduate.
Well, hopefully I won't stop you.
I'm Morgan, I'm a bio major, and I also want to scuba dive. So.
Okay, sweet.
I'm Lauren, I'm a bio major, and I want to wing walk.
You want to, sorry, what?
Wing walk.
Wing walk? What's this wing
It's
walk?
like where you go in a plane and like you stand on the plane and like you strap yourself into it.
Oh.
And then like they like take you upside down. And
Like
stuff.
on the wing of the plane.
Well, it's really like on the center, but they call it wing walk.
Okay, oh my.
Because you're literally standing on the plane as they're like flipping upside down.
But that's really cool. Okay.
What's up, y'all? I'm Lane. I'm a computer science major, and I would like to bungee jump before I die.
You got some like thrill seekers in the crowd today.
I'm Raj, I'm an undecided major, and I want to skydive.
Sweet.
I'm Griffin, I'm a mechanical engineer, and I'd like to see the Parthenon.
The Parthenon. Very cool.
I'm Gavin, I'm a marine science major, and I probably want to go the entire Appalachian Trail at some point.
Oh yeah, I had a friend who did that. His trail name was Laser. Apparently when you're on the trail, like you're not supposed to like refer to each other by like your real life name. You're supposed to get like a trail nickname.
It's because like, if you car something on like a trail or something like that, they can arrest you if like you use your regular name.
Oh really? Okay. Yeah, I guess I'd avoid that.
I'm Haley and my voice is like gone today for some
Oh, that's
reason.
okay.
I'm a biological sciences major and I want to visit a revolving theater.
Revolving theater, what does that entail?
So it's like the stage kind of rotates and there's like a screen that moves.
Oh,
and
okay.
It aids in scene transitions and I just think that's like the coolest thing ever.
Yeah, that is really cool. Cause like, I guess it would remove the need to like close the curtains and then like change the set and then open the curtains, theoretically.
And like it would allow you to construct more detailed sets because you wouldn't be like dismantling it every time.
Yeah, yeah.
And just seems real cool.
Very cool. All right.
My name's Grayson. I'm a civil engineer major,
Alright.
and I probably just want to stand up too.
All right, nice.
Hey guys, my name's Zane, I-Tech major, also part of the marching band. One thing I would want to do for LA is probably just start a professional symbol line.
Professional what?
Symbol line, like.
What is that?
So you know, like this, the symbols that like are for like that they do in the marching band, like. It's just like not like concert symbols, but like.
Oh, symbol line.
Like,
Oh,
yeah,
I got you. Okay, so you want to produce the symbols.
Yeah, like I'll
Okay.
teach you like fine, but.
Very cool.
There's other details about that, but yeah.
All right.
My name's Brecken, I'm a biochem major, and I probably just want to like travel more.
Okay.
My name is Achilles. You can call me Aki. I'm majoring in economics, and I'd like to learn one dish from each country.
One dish. So you like to cook, huh? I like to cook too.
My name's Mia, I'm a marine science major, and I also want to scuba dive at the Great Barrier Reef.
Okay, very cool.
My name's Jesse, I'm a biology major, and I also want to go out.
Okay.
My name's Liam. I'm a civil engineering major, and I want to skydive too.
My name's Ruth, I want to travel to Europe, and I'm a chem major.
You're a chem major, you said?
I'm Maya, I'm a statistics major, and I probably just want to travel more.
My name's Sarah Kate. I'm a biology major and I'd like to skydive.
I'm Veronica, I'm a biochem major, and I just want to travel like as much as I can.
Yeah, that's a good way to live.
I'm Alexandra. I'm a chem major and I want to travel.
Alright.
I'm Jasmine. I'm a biology major and I probably just want to travel.
I'm Andrew, I'm a biology major, and I want to publish a book.
Publish a book? What are you going to write about?
Probably fantasy.
Fantasy. Okay, cool.
I'm Kayla. I'm also
people call me by Lorenzo.
Lorenzo?
Yes,
Okay.
sir. I'm also in the marching band. My major is computer engineering, and I probably want to skydive right now.
Cool.
I'm Kevin. I'm a cyber intelligence major, and I just want to travel.
Okay.
I'm Jenna. I'm a biology major, and I think I want to bungee jump. I haven't decided that yet. I think I do.
You can decide when you get there.
Yeah. Just leave.
All right, sweet.
I'm Alexa. I'm a biology major, and I probably want to retire in Greece before I
Retire in Greece. Any particular reason why Greece?
I'm Greek, but I've lived in many countries, but never Greece, so I want to do that.
Gotcha. Do you have family in Greece?
I do.
Okay, nice. That should make it easier. All right.
I'm Colin, I'm a biological science major, and I probably want to skydive.
All right.
I'm Ian. I'm a marine science major, also in the marching band, and I probably want to go to the deepest part of the ocean before I die.
Mariana's Trench. Is that what it is?
St. John the Deacon's.
Oh yeah, I think that is in the Marianas Trench. Or maybe not. We'll fact check that. Okay, fantastic. Well, it's wonderful to meet you all. Man, a lot of scientists. This is kind of cool. I feel like in 115, a lot of the time I get more humanities students. But all right, that sounds very cool. Well, it's going to take me a while to learn all of your names. There's kind of a lot of you. But I'll do my best to learn them as fast as I can. What I thought that we could do now is go through the syllabus. So let me switch documents here. And I have posted this syllabus onto Blackboard. Has anyone been able to see the syllabus already? Some people have? Okay, great. Well, if you read it before, this will be a review. Otherwise, just going to communicate this information to you verbally so that you're aware of all of it. And you don't need to take notes on this or anything. You can just listen because the document is on Blackboard. So if you ever need to go back and check this, okay, the place you go is you go to Blackboard and you go to Our Class, and then on the sidebar there will be a little sidebar, and there will be course content and then syllabus and schedule. If you click on syllabus and schedule, it will take you right to this document. Or actually, I might update this document a little bit more before I finalize it. But we're going to go through all of the important stuff now. So first of all, class is pre-calculus, 115, section 002. You don't really need to remember the section number at all. But one thing that you do need to remember is where we're going to have class, which is confusing because it's different on Monday and Wednesday than it is on Tuesday and Thursday. So same building, different room. On Monday and Wednesday, we are in room 450, which is on the 4th floor, obviously. And it kind of smells in there, to be honest. I went in there the other day and it was kind of stinky. But we're going to deal. When we have exams, they'll be in that 450 room, with the exception of the final exam. The final exam will be in this room. But don't worry, before we have an exam, I'll remind you 1,000 times of the location and the time. So no need to memorize those yet. Okay, my email is the most important thing that you need to remember from today. That's how you get into contact with me. I usually respond to emails within 24 hours. So if you ever have a question about the syllabus or a problem on the homework, or you want to meet with me but you can't come to my office hours because you have a class at that time, email me. That's the best way to get into contact with me. My office is in the LeConte building, LeConte 439. Now, LeConte is currently under construction. So I wonder if there's a way that I could make this go away. Do you think I could do that somehow? Maybe not. Okay, well, it'll be there for now. So LeConte is the math building, which is still kind of under construction. So it was supposed to be done by now, but surprise, surprise, it's not done yet. And so for the first couple weeks of the semester, I'm going to be doing my office hours on Microsoft Teams. So did anybody receive an email with an invitation to my Microsoft team? Okay, great. So to use Microsoft Teams, I think you need to download the app. But basically, the way that it will work is you will log in to Microsoft Teams at the time of my office hours, and then you will click Join Meeting, and I will be in there on the other side. You'll be able to see my face, and you'll be able to see my iPad screen. Okay, so if you have a question on like number 3 on the homework, then I'll write down the question, and then you will write it down on your piece of paper in your location, and then we'll work on that problem together, and I'll just ask you questions verbally as we go along. It's not as good as meeting in person, but it will do for the first few weeks until I get back into my office. So speaking of office hours, they're going to be on Monday and Wednesday from 10 to 11:30. I may change that, especially if people are telling me that, like, if a lot of people are telling me they have class during that time, then I'll probably move them. But that's kind of what I'm thinking right now. So on Monday and Wednesday, our class ends at 9:20. So I'm basically going to walk from this building over to the math building, or from this building to my house for the first couple of weeks. And then I'll be ready for office hours, like right after class. So it's kind of nice if you want to, like, if you have some questions from class that you want to ask during office hours, you get to just kind of do it right away. But yeah, I might change that still. Okay. So, okay, yeah, remark, this syllabus is subject to change. I still may change a handful of things in here, but most of this should be pretty well set. Okay, prerequisites, qualification through the placement exam, or a C or better in Math 111 and 111I. In my experience, the placement test leaves something to be desired. And when I teach this class, or when I teach 122, which is the business calculus class, I find that usually I have a handful of students who are very over-prepared for the class, and I have a handful of students who are somewhat under-prepared for the class. So the best thing that you can do if you think you might be in one of those camps is get ahead of it early, because if you're in 115 and you really should be in a calculus class, I can try to recommend you to go up or something like that. I don't know how much power I have to do that, but if you are in the latter camp and you really need to still work on some of those algebra skills, trust me, you will be far, 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 far better off taking a semester and doing 111 rather than trying to kind of push through and do the 115. So no judgment from me. Everybody is sometimes at different levels depending on where you're at in your math education. So we just want to make sure that you're in the right class. So if you think you might not be in the right class, just come talk with me and we'll suss it out together. Okay, learning outcomes. You can read these on your own, I guess, but basically we're going to do algebra, trigonometry, we're going to do some graphing, we're going to learn about polynomials, we are going to do rational functions and exponential functions. What else are we going to do? Of course, anytime we talk about a function, let me get my pointer going here. My pointer does not want to work. What is happening? Oh, I think it's because my pencil's not paired. Hang on. There we go. Okay, sweet. And we gotta get the trail on. Okay, so anytime we are talking about functions, we need to be talking about, of course, the domain and range of those functions, whether the function has an inverse, and these sorts of things. We're going to learn some identities about trigonometry, about how to take various sine and cosine and tangent and SOHCAHTOA and how to reverse those and rearrange them. And generally, the problems are going to require more than one step to solve. Okay, so there's a little bit of a an adjustment coming to college math if you are used to high school math, because at the college level there's really a much larger focus on conceptual understanding as opposed to standardized test results. So, you know, the exams are generally going to be very forgiving in terms of partial credit, but there's also going to be a much larger focus on the process than there is necessarily on the answer, which in my opinion works 95% of the time in the student's favor, but I just want you to be aware of that slight difference. Any questions so far? Okay. If you have any questions, then please just raise your hand and I'll interrupt and cover that. Okay, the textbook. You don't need the physical textbook is my main thing to say here. And in fact, I suggest that you refrain from purchasing it because it costs money that you could better spend doing literally anything else. If you get the My Math Lab subscription, which you need to purchase in order to do your homework, it comes with an e-textbook. So you can click through the textbook. It's like an online PDF, basically. So that is probably more than you will ever need. Everything that we're going to learn, we're going to talk about in class. If you want to read the textbook, okay. Supplemental instruction is never bad, but it's probably not necessary for like 95% of you. Okay, online materials. Speaking of My Math Lab, you need to get a My Math Lab account. So the way you do that is you go to Blackboard, and I have instructions posted on the Blackboard of how do you gain access to My Math Lab. I think you have to pay like $75 or something like that. That gets you access to the e-textbook and the homework for the semester. So you do need to pay that, and you should go through the link which is on the Blackboard because that is a personalized link to our class. It will send you to register directly for this class. Calculator. You may find a calculator helpful at times. However, calculators will not be allowed on exams. Okay, the reason being is 90% of calculators are able to do trigonometric calculations like sine of pi over 2 or cosine of 0, stuff like this, which is going to be like a fundamental building block of like the learning of this class, is to actually understand the unit circle and be able to compute trigonometric functions without a calculator. So for that reason, on exams, I will give you very nice numbers. Okay, everything will work out to be like 5 or 1 or 0 or maybe a half or something like that. But it will all be numbers which you're familiar with in class, familiar with on the homework. I'm not going to make you carry out decimals to like 9 places without a calculator. I'll make everything very nice. You can use calculators on the homework if you want, but I would just give you a word of caution to not become overly dependent on them because you won't be able to have them on the exam. Okay, face coverings are optional unless otherwise indicated by university policy. If you have any cold-like symptoms, okay, if you have a cough or a sore throat or anything, okay, do not come to class, send me an email, and go get tested for COVID-19, okay? You can do this for free at either the Coliseum or at the Russell House or like a handful of other places. You can get free COVID-19 testing. Just don't come if you have any symptoms whatsoever or if you have been close to somebody who has symptoms that are COVID-19 like, okay? Yeah, I put a link in here for the COVID guidelines. We'll see how those evolve over the course of the semester. Communication with me, I think I already said the best way is via email or come to office hours if once my office hours are in person. Oh yeah, if you have an administrative question, like when is the first exam? Please check the syllabus before sending me an email about it because most of the answers to administrative questions like that, I've worked very, very hard to get them all into this document for you. Okay. Attendance. Students are expected to attend every class except in the case of an excused absence or in the case of a COVID exposure, like I had just said. I will be taking attendance. I'm not taking attendance today. I'll probably start next week. At the start of each class, just to keep a record of who's here, but I'm not going to assign class credit for attendance. Oh yeah, assignments and assessment dates will not be adjusted for personal reasons, such as a family vacation. Yep.
For like the math lab thing, should we do the 24 months or the 18 weeks?
18 weeks will take you through the end of the semester. Is it cheaper? It should be cheaper, right?
The other one's like $108.
Yeah, I mean, unless you want to have access to the e-textbook and your homeworks from this class next semester and the semester after that and the semester after that, which I think most students typically don't need that. So I would just recommend go with the cheapest possible option because y'all are college students. Okay. Where was I at? I just finished attendance. Oh yeah, I'm not assigning credit for attendance, but I will be keeping a record of who is coming. Every year I get somebody who says, I want to go home early for winter vacation. Can I take the exam like a week early? And the answer is unfortunately no, I can't afford to do that because it requires so much time out of my schedule to write a specific exam for you, and then of course I can never make it exactly the same or equivalent as the other exams, and it just throws a whole wrench into everything. You need to make sure that you are going to be here for the days of the exams and the final. Not trying to be a hard ass, it just has to be that way. Okay, participation. I think that it's great if you can participate in class. I think that the students that I have had in the past, I've been teaching for 4 years, every single time, the people who are participating in class, who are asking questions, who are coming to office hours, these are the people who routinely get A's. It's just the way that it is. If you're engaging with the material, I promise you, you will learn far better. So, even if you don't want to, raise your hand and answer a question during class, that's totally fine. But if there's, if there's dedicated time to like, okay, we're going to work on this problem on our own for a minute, then do your best to give it the old college try, and just give your best effort, and I think that you will reap the benefits. I have to talk about academic integrity every time I start a semester like this. They're extremely important. My policy on academic integrity is that if I observe any evidence whatsoever of an academic integrity violation, I am going to send it to the people at the Office of Student Conduct, and I'm going to, remove my hands from that subject entirely, and whatever they determine will be the outcome. So students are basically subject to disciplinary action contingent upon their determination. I'm going to tell them what happened, they're going to figure it out, and then tell me what to do. Any questions about academic integrity? Okay, it's usually not a problem, but I have to talk about these things before I start. Okay, if you are registered with the SDRC, so you get like time and a half on exams or double time, then what you need to do is make an appointment with me outside of office hours or in office hours, depending on your schedule. But it needs to be a one-on-one appointment with me where we discuss how we're going to implement your accommodations during class. So if you need to sit at the front, then I'll reserve you a seat at the front. If you need time and a half on exams, I will send your exams to the SDRC and you will go there to take the exams. Studying. This class meets 4 times a week for lecture for a total of 4 hours. It is suggested that the students study for at least 2 hours outside of class for every hour within class. So this is another massive difference between high school math and college math, is basically the amount of time which you have in the classroom with me is like, I worked it out one time, it's like a third of what you would have in a high school class. Okay, so what that means is that during class, I basically have to focus on covering, just kind of exposing you to material. So in high school, what you do is you learn the material, and then for like 10 minutes, and then you spend the rest of the 40 minutes of the class doing exercises or doing group work or doing this, that, or the other to try to solidify those concepts. In college math, it tends to be more the entire class time is spent on kind of exposing you to these ideas and showing you a handful of examples. And then the bulk of the training that you will do will be through the homework. Okay, so the homework is going to be how you actually like learn the material. So what I always say is that math is not a spectator sport. It's you need to actually be doing math in order to learn math, right? So like if I want to be an amazing tennis player, right, it's not enough for me to like go to the US Open and watch Roger Federer play and be like, wow, I can tell that what he's doing is correct, and that's definitely what I need to do, right? I need to go actually to the court and, you know, practice and actually do it myself in order to get the concepts down for myself. So it's the same way for math. In class, for the most part, I will be exposing you to the ideas, and then the homework is where you practice those ideas. So essentially, not as much in-class practice. I would love to incorporate more, but we're going to have a lot of things to cover, I think. Okay, makeup policy. If you have an excused absence, it's 48 hours. Actually, just send me an email and we'll work it out. But I have to put something in here. So 48 hours generally is the rule, but if you need longer, then just send me an email and we will discuss. But that's the general policy. Okay, COVID and mental health. Well, actually just mental health in general. COVID, less important now. College is a really hard time for some people. I know college was a really hard time for me, my undergrad. And it's very important that you curate your mental health, and there are a variety of resources which you can use to do so. First and foremost, if you feel like you are just drowning and it's just not going well for you, just want to let you know that you can come and talk with me. Okay, my office is always open. If I'm in there, you can come by and we can chat, and I can get you connected with some like more permanent resources. Speaking of more permanent resources, the Counseling and Psychiatry Center, okay, they offer every U of SC student something like 10 free counseling sessions per academic year, I think. I've personally made use of that service, and I found it is extremely helpful. So you can go, schedule an appointment, get a triage, and start curating your mental health as well as you possibly can, because it's important. Okay, statement of inclusivity. So this is a common math letter that I actually signed. Basically what it says is that I will not discriminate against you in terms of grade based on your race, sexual orientation, gender identity, disability, age, anything, okay? I will treat all of my students not only equally, but actually equitably, okay? I recognize that I am a person who comes from a privileged background, and that my teaching is going to align with, you know, probably what I would have wanted when I was your age or something like that. And that's not necessarily best for everybody, so if there's something that I can be doing to better accommodate you, then please let me know. There are 2 ways that you can do that. Well, 3 ways. You can send me an email, you can talk to me in person, or if you don't want to be identified, I have an anonymous feedback link on Blackboard where you can go and click the anonymous feedback link and say, hey, I'd like you to modify your teaching in the following way because it's impossible for me to learn doing it the way that you're currently doing it, something like that. So you can also use that if you have general comments about the class that you feel like it could be improved in some way. You can use that anonymous feedback link. Of course, I will try to actually address those comments during class. I'll say, okay, someone on the anonymous feedback said this, so here's what I'm going to do about it or not do about it, and here's why. So, you know, if you say, please remove homework from the class, I'm probably not going to be able to do that, but yeah. Okay, speaking of homework, So these are the assignments that we're going to have. So there will be homework assignments regularly on my math lab. I'll let you know when they are due, and I will keep it updated. Right now I have a ton of assignments in there, and I think that right now they're way too long. So I need to pare them down because I actually copied those assignments from another instructor, but I think it's just way too many problems. So I'm gonna pare those down, don't worry about them. What I have them all set to right now is to be due at the end of the semester. As we go through the semester, I will update the due date of the relevant homework for the relevant week that we are working on, because it's impossible for me to predict how far behind I will be, and it's a nightmare to like move all of the dates back by a week individually. So the lowest 2 homework assignments will be dropped, and every homework assignment will be weighted equally. Now, on the homework, it's on my math lab, which allows you unlimited attempts per problem. So you can go and try the problem as many times as you want until you get it right. And you can also come to my office hours and ask me about a problem, and we will work through it together, and you can put in the answer that we accomplished together, okay? Or if I'm not sure if we're gonna have an SI, but I think we're gonna have an SI. Same deal with them. If you go to the supplemental instruction sections, or if you go to the Math Tutoring Center, I give you full reign to work on homework problems with other instructors and with the supplemental instructor and with me during office hours. With all of this in mind, with all of the resources that you have and the unlimited attempts, I think it's very reasonable to try as students to get 100% on every homework. You know, you can try the problems on your own, then come to office hours, then go to the SI sessions. Like between all of those resources, I think that you should be able to get 100% on every homework. Usually not everybody does that, but I just want you to let you know that it's a perfectly attainable goal to try to go for. And it's also extremely helpful if you do that, because the way our grades work is via this weighted grade system. So you can tell that it's weighted heavily towards exams, which means that any points that you can guarantee yourself on like the homework are gonna be worth every penny, because the homework's worth 20%. So get as much of those points as you can to make up for in case you have a bad exam or something like that. Okay, quizzes will be given periodically. I have the quiz schedule below. We'll look at that in a second, and I will always announce what content is gonna be on that quiz at least 2 days in advance. So I'll say, okay, don't forget there's a quiz this Thursday, and we're covering sections and and I will give those during the last 15 minutes of class on a Tuesday or a Thursday, so that'll be this room. And there are gonna be a total of 7 quizzes, and the lowest 2 quizzes will be dropped as well. So between quizzes and homework, you know, you could really miss like basically a week of class or even 2 weeks of class probably. And, you know, this isn't gonna hurt you. So I've built that in here just in case anybody gets COVID or something like that, they get so behind. I don't want that to harm you. Okay, midterm exams. There will be 3 50-minute midterm exams, and they will be short. The schedule is below, so that's in the other room. So they're all on a Wednesday. Wednesday, September 14th, Wednesday, October 19th, and Wednesday, November 16th. So the midterm exam questions will be drawn directly from the pool of homework questions. Okay, so if you know how to do every single homework question, then you will know how to do the questions on the exam. Okay, so I'm not going to invent any new problems. I'm going to take them directly from the homework. So if you want to study for the exam, probably one of the best things you could do for yourself is to retry some of those homework problems and make sure that you know how to do them. Something new I'm doing this semester, so there's 3 exams, which is kind of a lot in addition to the final. And they're gonna be short. I'm gonna say that they're gonna be no longer than 3 pages long. They'll probably be like front and back. Maybe there'll be a 3rd page, depending on the material and how many pictures I include. But they'll be pretty short. I don't want time to be an issue for anybody. The only downside of the shorter exams is I have to pull from a pool of content, right? And if the stuff that shows up on the exam isn't the stuff that you spent as much time studying on, that can be frustrating. So you need to make sure that you have a kind of a broad stroke with your studying across all of the sections that are going to be relevant for that exam. So I just want you to be aware of that. But I think overall, I think most students prefer the shorter exams. If you don't, let me know in the anonymous feedback. Okay, final exam is cumulative. So the first 3 exams are generally like exam 1 will be focused on what we do up until exam 1. Exam 2 will be focused on what we do between exam 1 and exam 2. Now, math, as you know, is kind of builds on top of one another. So it's like technically cumulative in that sense. But generally, I'm not going to focus too hard on stuff that we already covered on a previous exam. Okay, extra credit. The lowest 2 homework scores are dropped. The lowest 2 quizzes are dropped. I don't have anything built in besides that, but I have occasionally in the past offered various extra credit opportunities, like a quiz retake if the quizzes went badly, or stuff like that. Grades. Final grades will be assigned on the usual scale. So A is 90 to 100. B plus is 87 to 89. I do generally round up if you're at like an 89.5 or something like that. The only thing different about this grade system is there's no minuses. For some reason, this university doesn't have minuses. So that's just how it is. Okay, be careful computing your grade during the course. I'm going to do the best I can to make sure that this doesn't happen on Blackboard, but it happens sometimes where Blackboard will give you like a total points or something like that. And because the grades are weighted on the syllabus, but they're not weighted on Blackboard, it gives you like a really bad idea of what your actual grade is. So just be careful to make sure that you're taking the weights into account. I'm going to try to make sure that that actually just automatically happens through Blackboard, but sometimes it doesn't behave well. So if you want to compute like what is your actual grade at a given time, like if you haven't done exam 2 and exam 3, it's really hard to figure out what is your grade going to be based on like, you know, just this like handful of things that you've already completed. So it's just a little tricky. Come and speak with me individually if you want to know where you're at in the course. Useful websites, Blackboard, Wolfram Alpha. My YouTube channel is here. You can click on it. Like, comment, subscribe. No, just kidding. Support. Okay, how can you get support? You can come to my office hours. You can go to the Math Tutoring Center. Well, once LeConte opens, you can go to the Math Tutoring Center. And probably they're doing something online. Anyways, the Math Tutoring Center is staffed by graduate students from 10 a.m. to 3 p.m. When we're in the actual LeConte building, it's like an actual physical classroom in LeConte. You can go there anytime from 10 a.m. to 3 p.m. And another graduate student, such as myself, who will definitely be able to help you with like Math 115 problems, will be in there and ready to assist you. You can definitely talk with those people about your homework problems, by the way. Also, the Student Success Center, okay, so they give more advice in terms of like how to be organized and how to have good study habits and these sorts of things, as opposed to like math-specific advice. Okay, so I always put this section at the bottom of my syllabus in terms of how to get a good grade / improve your grade. I'm not going to go through all of these. The only one I'm going to highlight is that the number one thing that you can do to help yourself succeed in this class is to go to office hours. Okay, if you can't go to office hours, you can email me and say, I can't go to office hours. And I will say, okay, do you want to meet on Sunday at 1 or do you want to meet on Tuesday night or something? Like, when is a good time? We will find a time to meet together. So I always say 1 hour in office hours with me is worth 4 hours or more studying on your own. It's just the best bang for your buck if you want to spend the least amount of time studying, getting the greatest amount of benefit. Office hours, office hours, office hours. But if you just pick like a handful of things off this list and you feel like, you know, you vibe with those things, then do those and they'll all help. I also put a section in here on how to study for an exam. when I came to college, I did high school and I like never studied during high school. I just kind of like showed up and it worked out okay for me. That did not work for me when I went to college, and it took me a while to learn how am I actually supposed to study for a math exam. So this is what you can look at if you don't know what you're supposed to be doing in order to study. It's probably not read the book. It's go to office hours, do practice problems, and that sort of thing. Okay, schedule here. We're gonna do a lot of stuff, but for the next 2 weeks, basically, we're gonna be focusing on Chapter A, which is appendix, and that basically has review. So there's gonna be a ton of review from algebra and algebra 2, basically, the high school classes. And that is gonna provide you with a great opportunity to see whether or not you're really like prepared for this class. If you struggle massively with the things which are in the appendix section, that can sometimes indicate that you might want to switch over to a Math 111 class. So those appendix sections we're going to cover really, really fast. So just make sure that you're keeping track and saying, okay, yeah, I remember that, or I'm not sure I remember how to do that. Got to ask about that during office hours. And here's the quiz and exam schedule. So the first quiz is going to be on August 30th. That's like, what, 12 days from now. That's going to be one of the first quizzes, and then you can go look at this online and put all of these into your planner or your calendar or your phone or whatever, and you'll never be surprised about when the exam is or when a quiz is. You shouldn't be anyway, because I'll be announcing them in class, but good to have the schedule. I tried to schedule the second midterm exam after fall break, because the other option was to do it like on the Tuesday before we leave for fall break, or Wednesday before we leave for fall break, which some people leave early, so I didn't want to do that. Likewise, the November exam is, I think, a week before Thanksgiving break, or maybe 2 weeks before Thanksgiving break. Okay, final exam is going to be at 9 a.m. on December 6th in our usual classroom. That's this classroom. Okay, I know I just like word vomited a ton of information at you. But does anybody have any questions about any of the topics which I covered on the syllabus? Yes?
Are the quiz and testing subject to change?
No, I'm going to
Stick to that.
I'm going to stick to that. I will, if necessary, I will change the content that will be on those quizzes to reflect whatever we have been talking about. But I like to keep the exam and quiz schedule fixed. That way, everybody can just put it in their calendar and not worry about accidentally missing class when they had a quiz. Any other questions? Did you have one in the back? No? Okay. All right, then let me ask another question. Does anyone have any questions or concerns or just general things to say or ask about regarding pre-calculus before we start in on material? Or just like, want to get an idea of what we're doing? No? Oh, yeah?
So you said these classes are gonna be like more lecture based, so like you tell us how the material works. Would there be like any time in class for like we do college?
Yeah, so I didn't mean to say that you won't be doing like in-class activities. There'll generally be like some group work. It's a little weird because we're in like this like rows setup, so we can't like push desks together and do like true group work. But maybe there will be like some work with a partner for a minute on this example, or some puzzles or things to work on in class. I try to mix it up because I don't think it's good if I just like spend the whole time talking. So yeah, there'll be some activities, but generally the pace has to be like a lot faster. So we don't get to spend as much time doing those activities, unfortunately. Any other questions? All right, then I guess we can start in on some material. So if you're taking notes, then go ahead and get your notes out. By the way, I post my notes onto Blackboard.
Where's my rules?
Okay, everyone situated? All right, so just a quick note, by the way, I try to upload my notes onto Blackboard, and usually my mechanism for doing this is I will write out what I call skeleton notes, just like unfilled in notes of what we're gonna talk about or whatever in advance. If I'm being good, I'll get this updated within a couple days ahead of time. So if you have a tablet or if you want to print this out at home, then you can print it out. I can also provide you with white background if you want white background for printing purposes. And I will generally write all of this stuff out in advance so that if you want to follow along, instead of writing your own notes, you can do that. But I like to write them out first just so that I remember what I'm supposed to be talking about. So the very first thing that I want to talk about is, you might think I'm crazy for doing this, but we're going to talk about PEMDAS, and then we're going to talk about adding fractions and multiplying fractions. Because sometimes people haven't done math in a while and they got to have a little refresher on some of this stuff before we get back into the swing of things. So first of all, PEMDAS tells us the order of mathematical operations, okay? So it's, if you want to remember it, it's not anagram, what do you call this? Anecdote, maybe? Yeah. Please excuse my dear Aunt Sally is the way that you can remember it. And it basically tells you the order in which you need to apply mathematical operations. So P stands for parentheses. And then E is for exponents. M is for multiplication. Actually, multiplication and division are in the same step. Multiplication, division, and then addition and subtraction can also be done interchangeably. So, okay, probably the only time that you ever encounter PEMDAS in daily life today is when you're on social media and someone posts like, oh, what is the order of operations? And then everyone is like frothing at the mouth in the comments saying that like, no, the answer is 16 or whatever. But it always has to do with, because they always use this symbol for division. And in real math, we never use that symbol for division. We always just take whatever we're supposed to divide and we put it over something else. Okay, well, we don't put it over 0, but we put it over something else. Okay, let's do a quick example. 5 plus 7 times 3 squared. Okay, so parentheses tells us that the very first thing we need to do is whatever is inside of the parentheses. So the first thing I do is I'm going to add 5 and 7 to get 12. And then I need to multiply that with 3 squared. So what comes next? Do I do 12 times 3? No, what should I do? I should square the 3 first, right? Okay, so we square the 3, we get 12 times 9, which, I don't know, is it like 72 or something like that? What is 12 times 9? No, it's not. It's going to be 108. What the hell am I talking about? Okay, 108. Haven't totally woken up today, I guess. All right, so there we go. So that's what we do for PEMDAS. Adding fractions. Okay, if I want to add 2 fractions, like 1/2 and 2/3 together, what is the first thing that I need to do? Find a common denominator. How do I do that?
Multiply the denominator.
Yeah, so I need to take both of these and I need to multiply the denominator times something which is going to get the denominators to be the same. in this case, the common denominator is going to be 6, right? So what do? I take 1/2 and I multiply the bottom by 3. And then on the other side, I multiply the bottom by 2. Is there anything else I need to do? I also need to multiply the top by the same number. Why do I need to multiply the top by the same number?
So you're not changing the fraction.
Exactly. So I'm not changing the value of the fraction, right? 1/2, if I multiply it by 3 on the bottom, it will become 1/6, which is a different number. However, if I multiply the top and bottom by the same number, then all I'm really doing is multiplying by 1, which will not change the value of the fraction. So if I do this, then I get 3/6 plus 4/6, right? Which, if I add those together, I get 7/6. So that's my answer. That's how I combine fractions using addition. Okay, I know we're probably falling asleep right now, but we got to go over this stuff and remind ourselves. How about multiplying fractions? What do I do if I want to do 2/3 times 1/7? Actually, why don't I go 4/7? What if I do 2/3 times 4/7? How do I multiply these guys together? So just multiply straight across, right? Multiply. Sorry, I feel like you all think this question is a trap because like you don't want to answer or whatever. But yeah, we multiply across. Okay, so the numerator gets multiplied by the numerator, and the denominator, which is the number in the bottom, gets multiplied by the denominator. And if we multiply these ones together, we get 8 on the top and we get 21 on the bottom. Okay, so this is how we add fractions and multiply fractions. Just a super quick review of that. And any questions on PEMDAS and fractions? Yes?
So you said you're going to post those like skeleton notes. Where will you post those?
On Blackboard.
On Blackboard?
Yep, there's a note which says, or there's a folder which says lecture notes, and I'll put in both the pre-notes, the skeleton notes, if you want to follow along in class, and I'll also put the updated notes after I finish writing them in class. I'll update them. Okay, so next up is preliminary set theory. Okay, so this is a topic which is, I think, a lot harder than what we were just talking about, and it's pretty important for this class because any time that we talk about the domain of a function or the range of a function, we will be talking about the domain and range in terms of set theory. Now, set theory is basically a catch-all terminology for the language we use to describe collections in mathematics. So I might have a collection of my favorite numbers. My favorite numbers are, I don't know, 3 and 7 and 9. Okay, so you can think of a set as like a bucket, and into my bucket I'm going to throw a handful of my favorite things, namely the numbers 3, 7, and 9. Okay, so let's see some examples of that. So first of all, a set is a collection of items. In this class, they will usually be numbers. Okay, so a couple examples would be the following. So I usually do these little squigglies, and I'm sorry in advance, I'm bad at the squigglies. But I'll do 3, 7, and 9. Okay, so this is a bucket. And in my bucket, I throw in my 3 favorite numbers, 3, 7, and 9. And this is a set, which I might call A. Okay, maybe I'll call it A. And whenever I write down A, I'm referring to the collection of these 3 numbers. Okay, or I could do B, which is like my 3 least favorite numbers, maybe -1, 0, and 7, because I feel ambivalent about 7. Okay? Or I could have, for example, an interval. We'll talk about intervals in a minute. But I could do C is all of the numbers between 0 and 5. I might write it like this. We'll talk about that notation in a minute. But a set is just a collection of numbers. But there's a little bit of there's a big difference between A, B, and C, right? Because in A and B, I've only got 3 numbers. How many numbers do I have in the set C? Well, in the set C, it's actually confusing, but I have infinitely many numbers. The way that this notation works is it actually refers to every single number which is larger than 0 and bigger and smaller than 5. Okay? So that includes numbers like 0.197364112. Stuff like that. Fractions, irrational numbers, all the numbers which are between 0 and 5. So we can have sets that have infinitely many members or elements, which is what the next thing is about. So a member or an element of a set is an item or number, for us, typically, is an item contained in the set. Okay, so the way that I usually write this, okay, is as follows. I will say, so let's remember that A is this set 3, 7, and 9, okay? If I write the number 3, and I want to express the fact that 3 is a member of the set A, then I will use this little sign like so, and then A. And what this means, what this symbol means, is in, or is in, or is a member of. Okay? So because the set 3, my bucket A has the number 3 in it, I say that 3 is in the bucket A, or is in the set A. Okay? Okay. Any questions so far on the set theory? Talking about collections of numbers. No questions so far? Okay. So now let's talk about the union and intersection of 2 sets. Okay, so let's remember what A and B are. Maybe I can copy them down. Copy. Paste. So let's remember that this is A and B. Forget about C for now. And let me move A over here. Okay, so we've got the union of 2 sets, A and B. So the way we write this is, well, first I'll give the definition, is a new set whose elements are all elements of A or B or both. Okay, the notation we use is we write A and then a big U for union, B. Okay, and you can loosely think of the U as meaning the word or, okay, because this set refers to the elements which are in A or B, or both. Okay, so the U, the big U means union, and it refers to elements which are in either set or both. So what would I get if I did the union of A and B here? I'm going to get a new set with a certain number of elements in it. And what is this going to be? Anybody tell me?
Like all the numbers?
Yeah, like all the numbers that are in A or in B, right? So let's start with the ones that are in A. I know this set should have 3 and 7 and 9 in it for sure, right? And it should also have -1 in it, because -1 is in B, and it should also have 0 in it. But I'm not going to rewrite 7 again, okay? The reason being is that this is a collection of items, of numbers, okay? And numbers are only identifiable by their value, right? So if I put 7 in there twice, it's kind of like relisting the same number again, okay? So I'm not going to relist it again, okay? It's just going to be in there one time. Okay, now the intersection is basically, well, we covered or, and now it's time to cover and. So the intersection is a new set whose elements are those which are common, are in A and in B. And the notation we use for the intersection is, rather than a big U, we just reverse that symbol and we do a big N, I guess. I don't know if you want to call it an N or an upside down U or what. I kind of think it's useful to think of it as an N because I think of this as like the stuff that's in A and B, as in A and B. I don't know. You can think about it that way if you want or not if you don't want. But in any case, it's going to be the collection of items which are in both A and in B. So what numbers are in both A and B?
7.
Just 7, right? So this is a bucket, and the only number in my bucket is just the number 7, because it's in both. And I'm not going to include 3 or 9 or -1 or 0, because while they are in one of them, they are not in both. Okay, so this is intersection. Okay, any question about union and intersection so far? All right. I usually try to give like a few seconds after I ask that in case somebody has to like work up the courage to raise their hand. Okay, let's talk about set difference and minus then. Well, the only difference the notation for set difference is as follows. So let me maybe write. We can form a new set by considering the elements which are in one set but are not in another set. And it's a little confusing because they use the word minus a lot when they talk about, or they use the word difference here, but it's not really subtraction as we understand it. So the notation is as follows. I would do A, and then I do one of these. A forward slash, or is it a backslash? I don't know. I think it's a forward. Is it a backslash?
Backslash.
It's a backslash. All right. Whatever. I'm not a typologist. I'm a mathematician. Okay. So what does this mean? What this means is we take all of the elements which are in A and are not in B. So A consists of 3, 7, and 9. I need to remove from the list any numbers which are in B. So -1, I don't need to remove because it's not in A already. 0, I don't need to remove because it is not in A already. But 7 is a number which is in A and in B. So I need to remove 7 from the list. So I would end up with just the numbers which are in A, which are 3 and 9, but not in B. Okay, because 7 is in B, I remove it from the list. All right, last set notation or set theory thing I want to say here is that we can also have a set which has nothing in it. And you might think, what is the point of having a set with nothing in it? But actually, the entirety of mathematics as we know it is built upon that notion. So if you want to learn more about that, we can talk about it in office hours. But basically, numbers, as we know them, would not exist without the empty set. So we denote it in one of two ways. Either we do a left squiggle followed by a right squiggle with nothing inside, okay? Which is the same thing as writing this symbol. Okay, when I write this 0 with a slash through it, or it's really more like an O with a slash through it, I guess, then that refers to a set with nothing in it. Okay. A set with nothing in it. Okay. So we're now going to discuss briefly classifying sets of numbers. We're probably not going to make it all the way through, but we're going to talk about a couple famous sets of numbers, namely the natural numbers, the whole numbers, the integers, the rationals, the reals, and complex numbers. Although we're not going to focus on complex numbers in this class, I don't think. So the first set of numbers that was ever really used by humans in history, right, was the natural numbers. Okay, so the natural numbers are all of the numbers that you can find like on your fingers, and then, you know, from there on, not counting people who have had part of their finger cut off. So if you count with fingers, we get numbers like 1, 2, 3, ... Okay, so positive whole numbers, which is a bit of a misnomer because now we're going to talk about whole numbers, okay, which the only difference between whole numbers and the natural numbers is we also include 0. So when I write ... like this, what I mean is that this pattern goes on and on forever. So for example, 1,500,017 is a natural number and also a whole number. Okay? It's also a whole number. Okay, and the last set of numbers that I think we'll talk about today will be the integers. Can anyone tell me what is the difference between the integers and the natural numbers and the whole numbers? They can be negative numbers. Okay, so now we do the following. I'll write -2, -1. I'll actually do a ... before, showing that that carries on in that direction. And then 0, and then 1, and then 2, and then ... Okay, to show that we carry on in both the forward and reverse direction. Okay, so they need to be whole numbers, so still no fractions. But they can be negative. Oh, one more thing I forgot to talk about was the notation for these two. The notation, if you want to know how to describe the set of natural numbers, you actually just do an n like this with an extra line. Or sometimes people do the extra line in another spot. And integers, the notation that we use for that is the same, except we use a z with an extra line like so. And those are the cool math symbols that we use to describe the natural numbers and the integers. Okay, we'll stop there for today. We'll do rationals and all the other numbers next time. Yeah, if you have any questions, then hang around after class. Otherwise, have a great weekend.